Yes, sir.
Yeah. So, as we discussed in earlier classes about different, we are done with the discussion of AP, GP, and HP. So these were sequences, and we also discussed AGP, arithmetico-geometric progression. More details here. Sum of n terms given by this formula, not so significant. Sum of infinite terms, very important. A by 1 by A upon 1 minus R plus dr into 1 minus R square. Now, what is AGP? Simple. The combination of arithmetic progression and geometric progression. It's like the multiplication of the term of a AP term and the common ratio of GP. This is typical AGP term, arithmetico-geometric progression term. Sum of infinite terms is given by this formula. Okay, let's look for an example. And now, please remember that the common ratio has to be less than 1, then only the sum of infinity can be calculated. Otherwise, it will get on increasing and tend to infinity when r is more than. Let's now solve an example. We have to find the sum of infinity of this series. Now, let's check what is this series belong to. Is it a AP, GP, HP, or AGP? Now 1 minus 3x plus 5x square. So seems like the degree is increasing regularly by 1. So uh, it can be a GP, but as we look for the common ratio, 1 by sorry, let's do it orderly. Minus 3 divided by 1, 5 divided by minus 3, minus 7 divided by 5. The common ratio is not common. The ratio is not common, so it's not a GP. Now let's check whether this is an EGP or not. For EGP, we have to break down the terms. So let's write them. 1 minus 3x plus 5x square minus 7x cube plus, this is going till infinite. If we break down this, we can write 1 minus plus 3 into minus of x. We can write 5 into minus of x square. I'm doing it intentionally. Now, if we observe 1, 3, 5, 7, so that becomes an arithmetic progression with common difference of 2. Can you see it?
Yes, sir.
Yeah. And the other term which is getting multiplied is minus of x every time. The degree of minus of x is increasing. Here originally there was x square. So x square can also be written as minus of x square. That's why I conveniently written so that you will be able to visualize and understand that there is a GP with common ratio of minus of x. Clear? So the sequence is what? AGP, not KGF. Have you seen KGF movie? Anyone of you?
Yes,
You
sir.
see? Yes, both of the parts.
No, couldn't get you, sir.
Both of the parts. KGF 1 and 2.
What
Go.
are
I
they?
was, I was asking ki both of the parts or only one part, KGF 1 and KGF 2.
Okay.
Okay. No answer. Let's do it. So this sequence is AGP. So there are infinite terms. The common ratio is minus of x here, right? Common ratio is, so for AP, the first term is 1 and is infinite for sure, and difference is plus of 2, and the common ratio is minus of x. Now the common ratio is less than 1 here because it is given to us that modulus of x is less than. So minus of x is definitely going to become less than 1. Okay, so we can apply this formula where r is less than 1. We have just studied this formula here, right here. Okay, so the sum of infinite terms for AGP when a is 1, on 1 minus of r is minus of x plus d which is 2 minus of r which is minus of 2, 1 minus minus of 2 whole square. Minus minus becomes plus, minus minus becomes plus. Here also minus minus becomes plus. So this becomes 1 plus x. This becomes 1 plus 2. Sorry, 1 minus r. So that becomes 1 plus 2 here. 1 by 3 minus of 4 divided by 3 square, which is 9. Taking 9 common, 3 minus 4 minus 1 by 9. This should be, no, we have done a mistake. We have mistakenly taken r as 2, which was the d. So there was a confusion here. We have ignored x. So apologies for the mistake. Humanly. 1 minus r. So 1 minus of minus x becomes 1 plus of x. D which is 2 into minus of r minus of x on 1 minus r. So minus of minus x becomes plus 1 plus x whole square. Now solving it further. So let's have a look on the options so that we know in which form we have to represent the question, the last line. So we have to take the denominator as 1 plus x square. So here also our LCM will be 1 plus x square only. One plus x whole square. Now this becomes 1 plus x. This becomes minus of 2x. So 1 plus x minus 2x becomes 1 minus of x divided by 1 plus x whole square. First option matches, which is the correct answer. Clear, everyone? Any doubts? No?
No, sir.
Yeah. Have a look here also. Any doubts, anyone?
No, sir.
What they have done here? Tell me what is happening if there are no doubts. They have gone with a different solution this time. They have multiplied minus of x with the series which was given to us. So if minus of x is getting multiplied, so 1 becomes minus of x. This becomes 3 into minus of x square. This becomes this. Basically, the degree is raised by 1 and also the signs are reversed now. So on adding both of these, sorry, on subtracting both of these, so the answer comes out this. Now they have modified the sequence to get a GP. This is clearly a GP with common ratio as minus of x. Now they have gone further on and solved this. Clear? Any doubts, anyone?
No,
If any, please ask. This solution looks like very premeditated. Anyways, we were discussing about sigma yesterday. Any doubts regarding this? No doubts?
no, sir.
Okay, so it's basically a operator. This is a operator which operates on a function. Function typically have variables. It may be happening that there are multiple variables, but we'll be dealing with the functions having single variable as per our syllabus. So the variable will have a lower limit here, and the upper limit will be written here. Then we'll start from the function's lower limit, every limit. Basically, let's take an example that there is a function starting from n is equals to 1 to n is equals to n. Then it means that f of 1, f of 2, plus till n has not come. Okay? It means that the sigma function, the sigma operation. So clear? Any doubts?
No, sir.
So just tell me the meaning of this now. Now, if I have not written any lower limit, that means that n is equals to 1, that the lower limit is 1. What it means, that this function will have first input as n is equals to 0. Sorry, n is equals to 1. So this is a constant function, so its output will remain the same. For n is equals to 1. For n is equals to 2, it will also remain the same. For n is equals to 3, it will also remain the same. It will repeat itself as for n times. If one is getting adding up, if one is getting added up with itself for n times, it becomes n only. Okay, understood?
Yes, sir.
If there is a function n, then it means for n is equals to 1, the function n now becomes, let's say f of n is n. Now we will find out for f of 1, which is 1. Okay. For f of 2, because we are going from n is equals to 1 to n. So for f of 1, it will 1. For 2, it will become 2. For f of 3 becomes 3. And similarly, up to n. So this is basically the sum of natural numbers. Sum of n natural numbers. So if we find out, we know this is a arithmetic progression, isn't it? The common difference is, what is the common difference in between consecutive natural numbers? The common difference between 1 and 2. What is the difference between 2 and 1? Simple. 3 and 2, 4 and 3, 5 and 4, 6 and 5, 7 and 6, 8 and 7. 1, right? If you're not clear. So, there is a AP having A, the first term as 1, difference is 1, number of terms as n. So, Sum of n terms should be n divided by 2 into 2a plus n minus 1 into of t. So this becomes 2 plus n minus 1, and 1 getting multiplied by n minus 1 becomes n minus 1 only. 2 minus 1 make it n plus 1. So this becomes n into n plus 1 divided by 2, which is our result. It's very important for you to remember this. Clear? This is the sum of n natural numbers. These results are very, very important. Really very important. Now let's find out the sum of the squares of first n natural numbers. It can be represented as n squared. Okay. So similarly, this can be found out by n into n plus 1 into 2n plus 1 divided by 6. Okay. And if we have to find out the cube, the sum of cubes, first n natural numbers, then it will be given by n into n plus 1 divided by 2 whole square. Now, do you recognize this n into n plus 1 divided by 2? It can be written as n cube sigma. Do you recognize this? This is basically sum of n natural numbers whole square. Please take a screenshot, read this again and again. I believe that's enough time to read. Let's move forward if there is no doubts. If any doubts, you may ask. Okay, so as we have discussed about the sum of n terms special series, like sum of ones n times, that becomes n, very natural. Sum of n natural numbers, sum of squares of first n natural numbers. This is given by n into n plus 1 into 2n plus 1 divided by 6. Please remember it tactfully. And this is the sum of cubes of first n natural numbers. Natural numbers 1, 2, 3, 4, or counting basically. There are also more. sum of cubes of n natural numbers is divisible by sum of natural numbers. Why? Why? Because sum of first n natural number is given by n into n plus 1 divided by 2 whole square. So basically this is the sum of first n natural number square. So definitely the one factor will be sum of natural number, right? So the sum of cubes of n natural number is divisible by sum of natural numbers. I hope that's clear. There are some more observations. If there's a pattern like this, numbers 1 divided by 2, 1 divided by 6, 1 divided by 12. So let me write it in a different format also so that you can understand when it is not given in this given format. Like this is the nth term of this particular kind of series. So its answer will be n divided by n plus 1. Please remember this, very important. Coming over to the next, 1 divided by 6 divided by 24 divided by 3 into 4, 12 into 5, 60. Similarly, nth term is number to number, this one, the number second, that should be given by 1 by 4 minus of 1 by 4 minus 1 divided by 2 into n plus 1 into n plus 2. Okay, so please remember this form also. Both of the forms are important. This is more easy to learn, but also have a look on this so that you will be able to remind yourself that which kind of series is this. 1 divided into 2, that makes it 2 plus 6 plus 3 into 4, 12, plus 4 into 5, 20. Similarly, that will be n into n plus 1 into n plus 2, 3. Please remember each and every formula written on this page very clearly. Ask if any doubts. Okay, so now moving ahead, let's find out the sum of this series. So like if the given series are not in AP, not in GP, not in HP, or even not in even nor in AGP, then we'll look and find out the difference, the difference between terms. Like D1 is the difference between second and first term. D2 is the difference between second and third term. And similarly, like this. So now we will observe this sequence and look for whether this is AP or GP or HP. We can find out so by using their conditions. For AP, basically the any of the three terms, in any of the three terms, the middle term should be equals to the sum, the mean of the others basically. And here also the geometric mean of others. Here also the harmonic mean of others. Clear. If one is the case, if like let's say D1, D2, D3 are in AP, now what you will have to do, simply write the sequence given. Write the sequence given. First term, second term, second last term, and this is last term. And also write the sequence again, but this time write A1 down here, A2 down here, and similarly an minus 2 plus an minus 1 plus an. Now subtract both of them. So the left hand side will become 0. This will become a1 plus a2 minus a1 d1 plus a3 minus a2 d2, ऐसे करके. Okay, so something like this. And how many terms are these? N minus 1 terms. Dn minus 1. This is an AP, right? Or GP or HP. We know the sum of n terms of these three sequence. We'll find out. And after finding out that, and what will be left here? This minus of the nth term. Now the nth term will go on the left hand side. A1 plus whatever the sum is there. Now after finding out the nth term, so the nth terms right hand side, this is particularly a function in n variable. Now we'll apply the sigma. Now we have the nth term, right? This is a function of n. Now we'll apply the sigma here from uh, like wherever we need to find out the sum of n terms, the sum of infinite terms. For infinite terms, we'll apply till infinite. Otherwise, we'll apply for n terms only. And as there is a function, so there will be a polynomial function. As we already know, let's say if this is a function, this is a function, right? And if we apply an operator here and n, so what will happen here is that a into sigma operator of n cube plus b into sigma operator of n square plus c into, now these are constants, so that's why we are writing them outside. Sigma operator of n d into sigma operator of 1. So this becomes n into n plus 1 divided by 2 whole square. This becomes n into n plus 1 divided, sorry, multiplied by 2n plus 1 divided by 6 divided by 6. This is, we know, n. This is sum of natural numbers n into n by 2. So we'll solve this out and we'll have a particular answer for this. So this is how theoretically we are going to solve it. Let me show you an example now. Clear? Is there any doubt in this particular method?
No, sir.
Okay, so let's solve the same question. Next slide. So in this sequence, uh, if you solve it like this is the 2, this is 4 into 3, 12, this is 9 into 4, 36. So can you see it? Is this a AP, common differences of, the difference is not common here. Let's look for the common difference. This is common ratio. This is 6, this is 3. The ratio is even not common here. Okay, let's try to do something then. Wow, I have done many things. Now, what we'll do, You observe the given sequence. This is 1 square into 2 plus 2 square to 3 plus 3 square plus 4. So what we were doing earlier, sum of n terms. What we were doing earlier, we were having an objective to find out its nth term so that we can apply the sigma operator. So if we observe here, so the first term, so means this is basically the first term. This is the second. This is the third. Similarly going on. So would it, after observing this pattern, can we write that the nth term will be having n square here and n plus 1 into its multiple? Like if there is 1, 1 plus 2. If there is a second term, so 2 here, 2 plus 1 here. If this is the third term, so 3 here, 3 plus 1 here. If this is the nth term, then n square here and n plus 1 into the multiple. Right? So, and the nth term is n square into n plus 1. Is that clear? Everyone? So if this is clear, let's simplify it and write it as n cube plus n square. Now let's apply the sigma operator on both sides. This becomes sum of n terms. This is n cube, which is n square into n plus 1 whole square divided by 4 plus sum of first square of natural numbers. So this is n into n plus 1 multiplied by 2 n plus 1 divided by 6. Now let's observe the options. So yes, there are chances to have 12 as the LCM. Let's take 4 and 6. 12 can be an LCM because it's a multiple of both, least common multiple of both. 4 into 3, so 3n square to n plus 1 square. 6 into 2, 2n to n plus 1 multiplied by 2n plus 1. You can take n into n minus 1 common. That leaves 3n into n plus 1 plus, now n into n plus 1 is common, 2 into 2n plus 1 divided by 12. Divided by 12. So n into n plus 1 is common. 3n square plus 3n plus 4n plus 2 divided by 12. N into n plus 1. 3n square plus 7n plus 2 divided by 12. Let's see if there is any option. Yes, B is the option which is matching. Any doubts, anyone?
No, sir.
Great. So please observe the question. We have find it out. What is the nth term? So let's move ahead. Here also they have find it out the the nth term and then operated sigma operator, the summation operator on the function. Okay. So the next difference is method of difference. We have already discussed about the same. It is the same that we have discussed here. Here. It's important. Please have a note of this page. This is that we are finding the method of difference. Cool. Understood, everyone?
Yes, sir.
An represents the general or the nth term of sequence. Okay, let's look for an example. 3 plus 15 plus 35. The ratio is of 5. Now there is no integral ratio. There is also no integral ratio. The difference is 12 20 पता नहीं क्या है. So there is no common difference. Right? So this is absurd. Let's look and find out 3, 15, 35, 63. Now let's look. There's a common difference. 12, 20, what? 25 plus 3, 28. So let's see what is the common difference here. The difference of differences. This is the sequence of differences. Now, assuming this is sequence, the common difference is here 8. Now there is the difference here is also 8. This is what? Common. So this is what? AP. Clear? Clear?
Yes, sir.
Yeah. So in that scenario, we'll consider this as S of n and will have to subtract the same sequence once again, minus of S of n, but this time we'll write 3 under the next term, plus 15 plus 35 plus 63, so on and on. Here let's assume there's a last term and there's last term, second last term and this last term. So there will be a second last term here and the last term here. You understand why? Because we have shifted the whole sequence one place ahead. So this becomes on left hand side 0, 3 minus 0 becomes 3, 15 minus 3 becomes 12, this becomes 20, then 28, then something something, and then last minus of tn because we have multiplied minus in the whole sequence, right? So let's bring the negative part on the left hand side. We'll make it positive. 3 plus 12 plus 20 plus 28. Now 12 plus 20 plus 28 dot dot dot. If we observe this sequence only, how many terms are there? There has to be n minus 1 terms. Why n minus 1 terms? Because we are considering these differences only. One term was left. So n minus 1 terms are there. Okay. So this is an EP with A as 12, difference of 8 and number of terms is n minus 1. So let's find out the sum using the sum of n terms of EP formula. N minus 1 divided by 2, 2a. 2 into 12 plus n minus of 1. N minus 1 is the n, and that of minus 1 into d, which is 8. Now, the nth term. becomes 3 plus n minus 1 divided by 2. 2 into 12 are 24 plus n minus of 2 into 8. So that becomes 8n minus of 16. 3 plus n minus 1 divided by 2. 12 minus 16 becomes 8 plus of 8n. 2 cancels 8 by 4. This 8 also by 4. That becomes 3 plus n minus 1 into 4 plus 4n. N was left here, right? So we can take 4 common. This becomes 1 plus n. Now the sum of n terms is, sorry, not the sum of n terms. The nth term. The nth term is, this is the nth term. 3 plus 4 to n minus 1 into n plus 1. N minus 1 into n plus 1. Okay, a minus b into a plus b, that becomes a square minus of b square. This becomes 3 plus 4 into n square minus of 1. This is the nth term. Let's simplify and write it as 3 plus 4n square minus of 4. That becomes 4n square minus of 1. The nth term is simply 4n square minus of 1. 4n square minus 1. This is the function. Let's operate summation. Let's find out the summation till n number of terms. So this becomes s of n, sum of n terms. And on the right hand side, this becomes 4 into summation of n square minus summation of 1 till n. Now sum of first n natural number, sum of squares of first n natural numbers is 4 into n plus 1 into 2n plus 1 divided by 6. Okay, minus of sum of 1 till n number of times. So that becomes n only. So 4, 2, 3. 2 2s are 4, 2 3s are 6. So taking LCM as 3, that becomes 2 to n into n plus 1, 2n plus 1, minus of n. Sorry, minus of 3n. Now taking n common, n by 3 common. So 2 into n into 2n plus 1. So n into 2n becomes 2n square into 4 into 2, that becomes 4n square. Now n plus of n, so 2n plus 2n, so plus 4n, plus of 1, so plus 2, minus of 3, right? Minus of 3. Okay, let's solve it further here. Sum of n terms should be n by 3. We should have looked in the option. So n by 3 is there, yes. So n by 3 plus 4n square plus 6n and plus 2 minus 3 minus 1. So 4n square, where is it? 4n square plus 6n minus 1. A should be the correct answer. A should be the correct answer. A should be the correct answer. Yes. Any doubts, anyone? If not, please read it, observe, absorb. All the topics in the chapter have been covered. Congrats. So let's recap the chapter. So in this chapter, questions are asked very simply from AP. not from EP, GP, HP directly, but after mixing the concept of EP, GP, and HP. Okay, and also sometimes, most of the times, questions are asked from series part, just that we have discussed. A series of known GP, known AP, known GP, known HP sequences. Okay, so there you have to observe the given sequence and think for any idea to make the general term or to do something relative. Okay, and also questions are asked from AM, GM, HM. They are important. Let's have a look. If A, B, C, D are in GP, then they are also in continued proportion. A by B is to be equal to B by C is equals to C by D, which is the 1 by common of ratio. If A, B, C three numbers are in AP, then if they are raised to some power, then also they will be in a GP where X has not to be plus minus 1. If an AP consists of n odd numbers n odd terms, then its middle term is M. Then the sum of the AP is Mn. Okay. If there are n odd terms, which middle is M, so its sum of the AP will be Mn. Let's take an example. Let's say there are odd terms. So let's say there are 5 terms in the AP. There are 5 terms on the AP. So n is 5 here. M is the middle term. So this is M, which is 5. Sum of the AP, sum of AP means sum of all 5 terms has to be M of n. This is basically S of n. Okay, so let's find out what is S of 5. So n by 2 to 2a plus n minus 1 into d, 4 into d is 2. This becomes 2 plus 4, 2 plus 8 basically. That becomes 10. 5 into 2, 5 into 5 becomes 25. And m was 5, n was 5. This is 25 itself. Yes, it is true. Example also verified this fact. वो देखो देखो अंगारे हैं सुल्तान. Okay, so let's now discuss the next point. If pth, qth, and rth terms of a GP are in GP, then PQR in EP. That was tough to understand, no? It is like let's say there's a GP. This is a GP. Now, if pth, let's pick any 3 numbers. These are in GP, all 3 numbers. Why? We can say that 32 square is 4 into 2, 5, 6. Let's try to solve this. So 32 square can be written as 32 into 32. So into 32. 4 8 ja, 8 3 ja 24, 8 2 ja 16. 32 equals 32. So it means these 3 terms are in GP. Now this is the second term. This is the 5th term. This is 6th, 7th, 8th term. So now if second, 5th, and 8th term of a GP are in GP, then 2, 5, 8 has to be in AP. So is it so? 2 plus 8 becomes 10. So 2 plus 8 divided by 2 has to be equal to 5. This is 10, this is 2. So yes, it is 5 equals 5. So this is how Pth, Qth, Rth term of a GP are in GP, then PQR will be in EP. I hope that is clear. Next point, the first term of a EP of a GP of n terms is A, last term is this, then the product of all terms is the geometric mean of this. So basically we have discussed this earlier also in geometric means. If ABC are in AP as well as in GP, then they has to be equal. If ABC are in EP, GP or HP, anything else, so according to that, A minus B by B minus C has to be equal to A by A or A by B or A by C. This is important. Please remember this. If nth term of a series is this, then the sum of its n, so it can be given as, okay, the operator. Sum of all possible product of first n natural numbers taken two at a time. Okay, this is the formula of this, I guess. Okay, I'll explain it more in tomorrow's PYQ solving class. Okay, now it's time for to conclude our class. Any other doubts, anyone?
No, sir.
Okay, shall we conclude the class?
Yes, sir.
Okay, thank you everyone. Jai Hind.
Thank you, sir.